Okay, so today we are going to do Chapter 5, Day 3. This is the third way we're going to learn to solve systems of equations, okay? Some people call it the elimination method. I actually call it the opposites method, okay? And you want to use this method when the coefficients are the same on one of the variables or when the coefficients are opposites on one of the variables. It actually works better when they're opposites, and you'll see why in just a second. So here is number 1. Now, the coefficients for the x's are 4 and 2. Great. The y's are the important part. Do you see how one of them is -3 and one of them is +3? That is always the goal, okay? We always want the two coefficients, the numbers in front of the variables, to be opposites. If they're the same, that's fine. We're going to multiply through by a negative to make them opposites. So the whole goal, that's why some people call this the opposites method. We want those to be opposites, all right? The reason we want them to be opposites, and here's the fun part, we can add the two equations together. All right, what is 4x plus 2x? Here's the magical part. What happens when you add opposites? Gone. Now the y's are gone.
Excuse me.
Yes.
We got to write plus 2x, 3, 1, but it's not on the thing.
Yeah, I think your notes only has one of the equations, so just fill in the other one and then we'll finish it.
So 6x equals
6x equals
24.
24. Good. Divide both sides by 6. X equals 4. Now, that's the easy part. The bad thing or the not as great thing about this method compared to substitution method, once you find the first variable, the second one's super easy, right? Here, the second one's not as easy. So you get to pick where you want to put the x. Where do you want to put the x?
On 2x.
This one?
2x.
A little smaller numbers? Okay, so I am going to put the x in the second equation. If you put it in the first equation, you should get the same y. Usually we just pick the easier one. You guys seem to think this one's easier, so we're going to go with it, okay? Now, 2 times 4 is 8. All right. When I subtract 8 from both sides, I get 3y equals 5. So y equals 5/3. So I think my answer is 4, 5/3, but I can plug it in to check. When I plug it in here, I get 16 minus, the 3's would cancel out, right? 16 minus 5, is that 11? It is. When I plug it in here, I'd have 8 plus, the 3's would go away again. 8 plus 5, is 8 plus 5 13? Yeah, so this does check out. Okay? So, again, this is just another way to solve these problems that you already know 2 ways to solve. Okay? So, if they're both in like y equals mx plus b, I'd go graphing. If one of the variables is already isolated, I'd go substitution. Here, the thing you want to look for is, do I have opposites? Can I get one of the variables to go away just by adding the equation?
Could it be this either one?
It can be either variable. You can have the x's go away when you add them or the y's go away when you add them. It doesn't matter. Now, a lot of times we'll tell you what method we want you to use, but in general, that's kind of where or why you'd pick one over the other. All right, so make sure you have both equations written in your notes. Do I have opposites on one of the variables?
On all of them.
Yeah, actually on all of them. So when we add these together, these are gone, these are gone. I have a 0 equals 0. Does 0 equal 0? Yes. So if I graphed these, I'd have two lines right on top of each other. What's the answer? Good. Good. So, again, think back to the graphs of these. If I graphed the same equation, just everything's opposite, it would end up being the same line. Okay? So if you get something that's true, it's all ordered pairs on the line. If we would get something that was not true, that would be when the lines are parallel and you have no solution. So those are the two special ones you want to look for. Questions? All right, here's number 3. Again, we're looking for opposites. There are no opposites. Do you see one we could very quickly turn into an opposite? So the 6x and the 3x. We could do the y's too, but since that's the first one I heard, I'm going to go with it. So, how would I make these opposites? I can multiply the bottom equation by 2. Would that make them opposites? By -2. So the whole goal is to make the equations so that we have opposite coefficients on one of the variables. You could have done the x, or sorry, we are doing the x's. You could have done the y's. Someone suggested the x's, so I'm going to go with it. Number 1 already had opposites.
Jesus, y'all didn't have to get on her like that. Oh, so we, okay.
So the first 2 examples we had opposites. Here we don't. So we're manipulating that bottom equation to make opposites. Yes, this, I bet you've seen this before. Okay, so since I'm changing the second equation, first I'm just going to write the first equation again. So I'm going to have 6x plus y equals 6. Didn't change that one at all. The second one, I'm multiplying both sides by a -2. So that's -6x minus 4y equals -18. This is absolutely not the only way to do this. Okay? But now I'm ready to add the equations. What happens to 6x and -6x? Those are gone. This is -3y equals negative. Negative what? -12. Okay. What do I get for y? 4. Good. Now, you can plug it into either of the original equations or either of the already multiplied equations. It doesn't matter where you plug it in. Plug it in somewhere. I'm actually going to plug it in up here where there's no coefficient. I mean, it doesn't matter. That looks easiest to me. So that's what I'm going to do. Okay. So what happens? So 6x equals 2. X equals 1/3. So I have 1/3, comma 4. I think that's right, but quickly I could plug it in. That would give me 2 plus 4 is 6. That's right. Here the 3's would go away. I'd be left with 1. Oh yeah, okay, 1 plus 8 is 9. That's true. What are your questions on number 3? So on this one, it's not as simple as the last ones. First of all, the first 2 problems we already had opposites. If we added them, one of the variables would be gone, would be great. The last one of the numbers went into the other one. 2 doesn't go into 3, 4 doesn't go into 6. So I'm actually going to have to multiply both equations by something. So what I'm going to do, I am going to go after the y's. What can I turn them both into? 6's. I'm going to turn this one into a positive 6. I'm going to turn this one into a negative 6. So I'm going to start by multiplying the entire top equation by 3. Then I'm going to multiply the entire second equation by 2. So when I rewrite these, I will have 18x plus 6y. Perfect. Very good. Okay. So again, the whole goal was to turn these into opposites. The 2 doesn't go into the 3, the 4 doesn't go into the 6. There wasn't really an option besides multiplying both equations. Now I have opposites, I can add them. What is 18x plus 8x? So I have 26x. The y's go away. 27 minus 14, or 27 plus a negative 14, is 13. When I divide both sides by 26, what do I get? 1/2. Good.
Wait, 13 half is
13 is half of 26, so yeah. No, not helpful. Not helpful. All right, plug it back in. It doesn't matter where you plug it back in. I just plugged it back in at the top. So 6 times 1/2 would give me 3. And then subtract the 3 would give me 6. Divide by 2. Y equals 3. So I think this is my answer. When I plug it back in, plug it into the original ones to check. In case you made a mistake from here to here, you'll catch it once you plug it into the originals. So 1/2 times 6 is 3. 3 plus 6 is 9. That one works out. When I plug it in here, I get 2 minus 9, which is negative 7. It checks out there as well. Questions? Okay, so do you see how the y's already have a positive and a negative? Yeah. I'm usually drawn to that variable just because it kind of eliminates the sign issue. So yes, we could turn those both into, somebody said it, 10s, right? The top is going to become a negative 10y, and the second one we're going to have a positive 10y, and the y's are going to go away. So to turn a negative 5 into a negative 10, you got to multiply by 2. To turn a positive 2 into a positive 10, we're going to multiply by 5. So up top, we are going to have 8x minus 10y equals 6. The next one will have 15x plus 10y equals negative 75. Yeah, so we already have the opposites. We're ready to add those. 8x plus 15x, 23. The y's are gone. What do I get in the back? Oh, good, because those will divide evenly, right? All right, when you divide negative 69 by 23, you get negative 3. All right. It doesn't matter where you plug it in. Once again, I probably wouldn't plug it in here just in case we made an error. You know what I mean? It's easier to just go with the originals. All right, so I'll go with the one that's a little smaller, less negative signs. I'm going to do it into the second one. So when I plug negative 3 in there, I end up with negative 9 plus 2y equals negative 15. Add the 9 to both sides. 2y equals negative 6. Divide by 2. Y equals negative 3. I think that it's going to be negative 3, negative 3. Let me double check. When I plug it in here, I get negative 12 plus 15. That's right. When I plug it in here, I have negative 9 plus negative 6, which is negative 15. So I'm good.